Now, let's go on, okay? So the first, here we do the exercise, okay? We have 10 antiderivative. The first one is the antiderivative of sine square. The second is antiderivative of cosine square. The third is the antiderivative of tangent square. The fourth is the antiderivative of secant square, okay? So number 5 is the antiderivative of secant cube, okay? Secant cube. The number 6 is the antiderivative of cosine cube. So the number 7 is the antiderivative of tangent cube, okay? The number 8 is the antiderivative of secant cube. So number 9 is the antiderivative of, no, the fourth part, the antiderivative of sine to the fourth part. Number 10 is the antiderivative of cosine to the fourth part. So now do it now, okay? So do it now.
Is this example?
Yeah. So you use this formula, okay? Use this formula to do here. Now, okay? Do it yourself.
In this example.
It's so easy, okay? You just use this one. It's so easy, okay?
And then you multiply to Okay, let's do it.
So use the number 1, number 4, okay? Or number 1, number 6.
But you said you're going to give us examples. No, I give us an exercise.
1 dx.
Yeah, I'm going.
So 1 is yeah, 1. So antiderivative of 1, not antiderivative of x. Yeah, great.
So in X, you use So for me, like this is good. So I read out the question. There's 1/3 plus 8.
Class C, I didn't give class C.
The duration was consecutive.
I didn't give class C.
Class C.
So if you found 1 cos x plus 1 yeah, cos x and 1/2 inverse cos x. Ne prima col 0. Half cos x and 8 plus 8/2. Haitasani kutoka na baki kwa nambari. That's why you would have sung up faster. Oh shit. Is this there? Number 2.
Actually, okay, for number 1 to number 4, we have 2 methods, okay. The first method is you can use the number 1 to number 4 formula. The second method, okay, the second method actually is sin square actually equal to what? Equal to 1 cosine 2x.
Yes.
1 minus cosine 2x by 2, okay? So you can use that formula, okay? It's the same. So you can use number 1 to number 4, okay? Here we have the integral sign here. Okay, here is 2 minus 2 power, so here should be cosine x to the 0 power, not cosine x. Okay. So the answer is right. Okay.
Este que bueno con un montón. Alba con Gagana.
Minus 7 cosine by a plus n minus 1 by a. So here, this is not the
Yeah, 2 minus 2. So 2 minus 1. Minus 2. Then 2 minus 2.
What's the difference?
No, see, okay. So number one, here we use number one formula, yeah? So here sin x square dx, okay? So here let n equal to 2, okay? Let n equal to 2 in the first formula. So here equal to what? Here equal to minus sin x, n is 2 minus 1 power, okay? Times cosine x. Times cosine x by n is 2. So the first term. The second term is plus, here is 2 minus 1 by 2, okay? So here is 2 minus 1 by 2, the antiderivative of sin x 2 minus 2 power. 2 minus 2 power is 0 power, yeah? So 0 power is what? Is 1, so here is 1 dx, okay? So the result should be minus half. Here is sin x, cosine x, and here plus 1 by 2, okay? Antiderivative of 1 is what? X plus c, yeah? So here is 1 by a half x plus a constant c. So this is the result, okay? So this is the first method, okay? The second method is what? So the second method is we can use the formula here. Sin x squared equal to what? Equal to 1 plus cosine 2x by 2, okay? So we introduce this formula, okay, at the first class. Here, sin squared equal to 1 plus cosine 2x, okay? Oh no, cosine 2x equal to 1 minus 2 sin x squared. So sin squared equal to, oh I'm sorry, here I make a mistake here. Here should be 1 minus, okay? Yeah, 1 minus. So 1 minus cosine 2x by 2. So here, the second method is sin x squared dx equal to the antiderivative of 1 minus cosine 2x by 2 dx, okay? So this is the second method, okay? So here is 1/2, so here is 1/2 antiderivative of 1 dx minus 1/2 antiderivative of cosine 2x dx. Okay? So here, this one is what? This one is 1/2 x. So this one is what? This one is minus cosine 2x antiderivative. Actually, it's 1/2 sin 2x. Yeah? 1/2 times 1/2. So 1 by 4 sin 2x plus a constant c. Okay? Actually, these two they are the same. Actually, these two they are the same. Okay, because sin 2x actually equal to what? 2 times sin x cosine x. Okay, so here actually should be 1/2 x minus 2 sin x times cosine x. So here should be 1/2 sin x cosine x plus the constancy. So they are the same. Okay, they are the same. So this is the second method. Okay, so you can use this formula. You can use this formula, reduction formula, or you can use sin square equal to 1 minus cosine 2x by 2. You can use, okay? This is the second method, okay? So for number 2, number 3, and number 4, actually, we have 2 methods again, okay? We also have 2 methods. So this is the number 1. Now for number 2, here cosine x square, okay? Cosine x square, here we use the formula 2, okay? So here for number 2, so cosine x square dx, we use the second formula, okay? We use the second formula, we let n equal to 2. So here, n equal to 2. So here is 1/2 times what? Cosine x 2 minus 1 power, so it's 1 power times sin x. And plus 2 minus 1/2, so it's 1/2. And the antiderivative of cosine x 2 minus 2 power. 2 minus 2 power actually is 0 power, so 0 power is 1. So the result should be what? 1/2 cosine x sin x and plus here 1/2 x plus the constancy. Yeah? This is the second, okay? And here the same. Cosine x square, okay? Cosine x square, you can use this formula. Here is cosine 2x equal to 2 cosine x square minus 1. So from here we now have cosine x square actually equal to cosine 2x plus 1/2. The second method, you can use this formula, okay? You can use this formula. So this is number 2. And number 3, okay? For number 3 here, tangent x square dx, okay? So tangent x square, we use the number 3 formula, okay? Number 3 formula, so here equal to what? So here actually equal to tangent x 2 minus 1 power by 2 minus 1, okay? So here is tangent x 2 minus 1 power by 2 minus 1, and minus the antiderivative of tangent x 2 minus 2 power. So 2 minus 2 power is 0 power, 0 power is 1, yeah? So here is dx. So the result should be what? So the result should be, here is tangent x and minus x plus the constancy, okay? So this is the first method, okay? The second method is tangent x. Tangent square equal to what? Tangent square, okay? We know that tangent x square equal to secant square minus 1, yeah?
Yes.
Tangent square equal to secant square minus 1, yeah? So here actually it's the same. So tangent x square dx actually equal to secant x square minus 1 dx. Yeah? So here this equal to what? So this equal to secant x square dx, yeah? And minus 1 dx, yeah? So secant square is what? So secant square antiderivative, which function derivative is secant square? Tangent x, yeah? So tangent x minus x plus c. So you can see 2 different methods, but the same result, okay? So here for number 3. Now for number 4 actually here is easy, okay? Number 4, second square. The antiderivative of second square is what? Second x squared dx. Actually we can use number 4, yeah? Number 4. So number 4 is what? So number 4 is equal to 1 by 2. Oh, no. 1 by 1. Okay, 1 by 1. Second 2 minus 2. So here is tangent x. So here is tangent x. Yeah. And plus here 2 minus 2. So here this term is 0. Yeah. So here plus the constancy. So we can use this formula, okay? Actually, we know that here second x squared, which function derivative equal to second square? Tangent, yeah? So this is equal to what? This is equal to tangent x plus c, okay? So this is the number 4. And the number 5. So number 5 is what? Number 5, okay, so number 5 is the antiderivative of sin x cubed. Sin x cubed, so sin x cubed, we use the number 1 formula, okay? Number 1 formula, so here is what? Here is minus sin x 3 minus 1 power, so it's 2 power cosine x by n is 3. So here is 3. And plus here 3 minus 1 by 3. So 3 minus 1 by 3. And here is the antiderivative of sin x 3 minus 2 power. So here is 1 power dx. So the result is what? So the result should be minus sin x squared. Here should be cosine x. So here it will be 3. And plus here is 2 by 3. And here is so antiderivative of sin minus cosine. Yeah, so here should be minus cosine x plus the constancy. Yeah? So this is the result. Okay? This is the result. And now for number 6. For number 6. Here is the antiderivative of cosine x cubed dx. This is equal to what? So use number 2, okay? Number 2 reduction formula, okay? So here equal to 1 by 3 cosine x 3 minus 1 power, so square, and sin x, yeah? And plus here is 3 minus 1 by 3, okay? 3 minus 1 by 3, and the antiderivative of cosine x, here is 3 minus 2 power, so it's 1 power dx. So here equal to what? So here equal to 1 by 3 cosine x squared. Here is sin x. And here is plus 2 by 3. The antiderivative of cosine? Sin, yeah? So here is sin x plus the constancy, yeah? So here is number 6, okay? Number 6. So for number 7. Number 7 here is tangent x cubed, okay? dx. Tangent x cubed, okay? So tangent x cubed, we use this formula, okay? We use this formula, so here equal to tangent x 3 minus 1 power, so square, by 3 minus 1, so here is 2. And minus the antiderivative of tangent x 3 minus 2 power, so it's 1 power dx. So the antiderivative of tangent x is what? So you should do remember this formula, okay? Number 5. So here equal to what? So the result is 1/2 tangent x squared and minus ln the absolute value of secant x plus a constant c, okay? Plus a constant c. So this is the answer for number 7. So what about number 8?
Now, she can just give us the formulas in the exam.
So this is the example.
No, like these formulas, you can just put for us like in the first paper of the exam, so that when the questions we can just. to be.
So
Just alone.
I know what do you want to listen. Yeah? So you want to listen. I tell you that I will not test the reduction formula in the final examination. Yeah.
Yes, please.
But actually, I will do not tell you.
Oh, wow.
Okay.
Wow. Amazing.
So here is number 8. Number 7, no, number 8. Number 8 is the antiderivative of secant x cubed, okay, dx. Secant x cubed dx. So here we use number 4, okay, number 4. So here equal to what? So here equal to 1 by 3 minus 1, so 1 by 2. So secant x, so here is 3 minus 2 power, so 1 power times tangent x and plus 3 minus 2 by, here is 3 minus 1, and here is the antiderivative of secant x, 3 minus 2 power, so is 1 power dx. So the result is what? So the result should be 1/2 secant x tangent x, okay, and plus here is 3 minus 2, so 1 by 2, so half the antiderivative of secant x. The antiderivative of secant x is here, ln. So here should be ln absolute value of secant x plus tangent x plus a constant c. So this is the result. Okay, this is the result. So here is number 8, number 8. So what about number 9? Number 9 and number 10. Okay. Number 9. For number 9 here, the antiderivative of sin x to the 4th power dx. This one, okay? This one, so we use the first formula. So here equal to minus sin x cubed. Okay, sin x cubed. So here is the cosine x. Here is the cosine x by what? By 4. Yeah, and plus here is 3 or 4 minus 1 by 4. So 3 by 4. 3 by 4. Here is the antiderivative of sin x squared dx. Yeah, and for this one, sin x squared, we use the formula again. Okay, we use the formula again. So here equal to what? So here equal to minus sin x cubed. Here is cosine x. Here is by 4. And plus here 3 by 4. Here should be what? Here should be here. So minus sin x cosine x by 2. Yeah, by 2 and plus 1 by 2. Here is the antiderivative of sin 0 square or sin 0 power. So here is this one. So the result should be minus sin x cubed cosine x by 4. Here should be minus 3 by 8. 3 by 8 sin x cosine x. Okay?
Yes.
And plus here is 3 by 8 x plus a constant c. So this is the result. Okay, so this is the result. Here is number 4 or number 9. So what number 10? Okay, so number 10 here. Number 10. Number 10 here is the antiderivative of cosine x to the fourth power dx. So we use the second formula, okay? So here equal to, so here equal to 1 by 4 cosine x to the cube, yeah? And the second sin x plus, here is 3 by 4, here is the antiderivative of cosine x squared dx, yeah? So here, now for this one, okay, for this one, here we use the formula again, okay, we use the formula again. So here equal to what? Here equal to 1 by 4 cosine x cubed, here is sin x, and here plus 3 by 4, so 3 by 4, so here should be what? Here should be 1 by 2 cosine x, sin x, and plus here 1 by 2 the antiderivative of 1 dx. Okay, so the result should be what? So the result, okay, so the result should be 1 by 4. Here is cosine x cubed, here is sin x, here is plus 3 by 8, here is cosine x, here is sin x, and here is plus 3 by 8 x plus a constant c. So this is the result, okay? This is the result. So I think that for this number 10, okay, it's easy, yeah?
Yes.
So easy, yeah?
Yes.
So just if you can use the formula, so it's so easy, okay?
Formula N, yeah.
So this is, so from here we can see that if you can remember this 6 formula, okay, it will be one important for you to solve the examination, solve the problem, okay?
Why can't you just give us the formulas in the exam?
So here,
Okay.
Chiwe cha quality. Chiwe cha quality. Cha kwanza ndani. Cha kutumia. Chiwe cha destruction. What's chiwe cha destruction? Age. Destructive.
Anna, I'm asking for it. Thank you, sweetheart. Anna. You're going to... Anna, code. It's a mass destruction, man. Bombay, what do you watch next last semester? I think that has to win. I remember. The Bombay was very,
Yeah, 49.
cosa bene. Cafungo. Breathtaking.
Just one human being. One human being.
Escaping.
Eu não, mas tem tudo no
Because of why? Because of why?
Now, okay. Now we will introduce the anti-derivative of another form, okay? Another form. So in this form, okay, in this form here, the antiderivative of sin x to the n power times cosine x to the nth power, okay, to the nth power dx. So now we will introduce this term, okay? So the antiderivative of this function, and the antiderivative of this function here, the antiderivative of tangent x. So here is tangent x to the n power times second x to the nth power dx, okay, dx. So here, for the antiderivative of these two, okay, these two, here we need to, here m, okay. So sometimes m is odd, m is even, n is odd, n is even, okay.
Yes.
So for this four case, here for this four case, okay. The first case is so here now we need to see here the first is n is odd. N is odd, so the second is m is odd, okay? So m is odd, so the third is m is even, and n is even, okay? And n is even. So here now for this four, okay? For these three cases, we have different method, okay? We have different method. So here now we can see the table, this table, okay? The antiderivative of sin x to the n power times cosine x to the nth power, okay? If n is odd, okay? So we split off of a factor of cosine x. The first step, okay? The second step is apply the here cosine x squared equal to 1 minus sin squared, okay? And now we make the substitution u equal to sin x. So this is the fourth case, n is odd. The second case is m is odd, okay? If m is odd, so here, if m is odd, we split off a factor of sin x. This is the first step. The second step is use the formula sin squared equal to 1 minus cosine squared. And the third step is make the u substitution u equal to cosine. So now for the third case, is m is even and n is even, okay? If m is even and n is even, so we just use the relevant identities to reduce the power on sin and cosine, okay? So we use sin squared equal to 1 minus cosine 2x. Cosine 2x squared or cosine squared equal to 1 plus cosine 2x, okay? So this formula we can use to reduce the power, okay? So reduce the powers on sin and cosine. So for this form, or for this two, we give an example. We give an example. So this example, okay. So here, so for here is the antiderivative of sin x to the fourth power. Here is cosine x to the 5th power. Okay, so dx. The first one. Okay, the first one. So the second one is here sin x to the 5th power times cosine x to the 4th power. Okay, dx. This is the second case. Okay, the third case is the antiderivative of sin x to the 4th power cosine x to the 4th power. Okay, dx. So here, so this is the, now for the first one, okay, for the first one here we can, here is even, 5 is odd, okay, odd. So here is odd, so for this odd, we split off one cosine, okay. So for the number one, here is sin x to the 4th power, here is cosine x to the 5th power, yeah? So dx. Because this 5 is odd, so we split off one cosine x, okay? So here we should write it in this form. Sin x to the 4th power, here is cosine x to the 4th power, and cosine x dx, yeah? We write it in this form. And now for this cosine x dx, okay, cosine x dx, so actually this is what? D sin, yeah? This is D sin, so here actually is sin x to the 4th power, here is cosine x to the 4th power, and here is D sin x, yeah? Because sin prime is cosine, yeah? So D sin actually is cosine dx, yeah? So here now, so from here, so we use the u substitution. We let u equal to what? U equal to sin, yeah?
Yeah.
So so from here we let u equal to sin. We let u equal to sin. So from here now, so we have what? So we have that here is u to the 4th power. Sin to the 4th power actually is u to the 4th power, yeah? And the cosine x to 4th power. So cosine x, we need to use plus with the sin. So cosine x to the 4th power actually equal to what? Equal to cosine x square, yeah? Square. So cosine square actually is what? 1 minus what? 1 minus sin square, yeah? Sin square. So sin we let it equal to u. So actually this part is what? 1 minus u square, yeah? So here means cosine square and cosine to the 4th power actually is 1 minus u square, yeah? And d sin actually is du, yeah? So du. So here now we can see that in this form. So here is we open it, okay? We open it. So here actually is u to the 4th power. Here is 1 plus u to the 4th power minus 2u square and du, okay? Du. So now we can see here is the antiderivative of u to the 4th power plus u to the 8th power and minus 2u to the 6th power, okay? Here, du. Yeah?
Yes.
So the antiderivative of u to the 4th power. So here is u to the 5th power by 5, yeah? U to the 8th power, u to the 9th power by 9, yeah? And here u to the 6th power, so minus u to the 7th power by 7, yeah? And plus a constant c. So now we should replace u by sin, okay?
Yes.
So the answer should be 1 by 5 sin x to the 5th power plus plus 1 by 9 sin x to the 9 power, okay? And minus 2 by 7 sin x to the 7 power, and plus a constancy. So this is the result, okay? This is the result. So here means for this two, okay, for this two, which is odd? Split one factor, okay? This 5 is odd. 5 is odd, so we divide the cosine x 5 power, we divide it by cosine to the 4 power times cosine, okay? So and this part we let it d sine, so we let u equal to sine, okay? So now we have a break, 10 minutes, okay?
I'm not going to do it. My book is finished. Finished. So, book done.
ग्रुप में मैसेज दाओ ग्रुप में मैसेज दाओ पढ़ो पढ़ो ग्रुप में मैसेज है पढ़ो फोन तो ऑन करो रिली